So in order to solve a problem, you really first have to understand the problem. If you look at the technology where it was in 2012 when we started versus where it is right now, it's like a world of difference. And this is really about being honest with ourselves, testing as much as possible, trying out many different things and see what works, what doesn't work, and taking those lessons into account. Researchers have been doing great work since the 1970s actually in terms of mapping plastic in this Great Pacific Garbage Patch. But the thing was that the data was very scattered, and we had this hunch that there was this measurement bias towards the smaller pieces. To solve that, we thought, well, what if we just cross this Great Pacific Garbage Patch with 50 boats at the same time, and that way we do cover a very large area and get a good sample of what is out there. By September 2015, we completed the mega expedition. We got all our samples in. It was a survey effort of unprecedented size. But while doing so, we collected a few ghost nets, which are these very large sort of balls of nets and ropes, which are very dangerous to marine life, to vessels as well. And the number of nets we collected was too low to do good science with, to do good statistics with, but it was high enough for us to have a suspicion that this would be actually a very major component of the problem. But to get a good analysis of these nets, we need to cover an even larger area. So that actually led to the first aerial reconnaissance mission of an ocean garbage patch ever. We crossed the Great Pacific Garbage Patch with a C-130 Hercules aircraft twice. We fitted this airplane with the most advanced aerial sensors in the world, which included shortwave infrared sensors as well as LiDAR sensors. And this is really the same technology that self-driving cars use, where we actually are able to get a sort of a 3D point cloud of the debris, through which we are also able to estimate whether it was just debris or a net at the surface, or whether it actually went down. So then we had the count, we had the volume, and through that we could actually estimate, based on the nets that we got with the mega expedition, how heavy those nets would be. And now it actually turns out that the nets that we spotted would actually comprise about half of the mass of plastic out there in the Great Pacific Garbage Patch. We have these 1.2 million pieces of plastic, and somehow we need to count them, and we need to turn this physical matter into data, into numbers. Within no time we found ourselves a group of interns. They started this monumental effort of actually separating the plastic from the plankton with a pair of tweezers, one by one, day in, day out, and I just have this immense amount of respect for the work that they did. And then it was really time to put the paper together. And really the challenge was to take this huge amount of data and then present it in a concise matter, compact enough so that we can actually submit it to a journal. So we use machine learning, evolutionary algorithms, things like that in our development for sure. So what's the most optimal location to place the cleanup systems? What's the most optimal shape of these barriers? A lot of design optimizations. We use complicated or intelligent algorithms for that. It has proven to be one of the main challenges, and we really kept pushing for it to keep the system as simple as possible, because anything that's complicated is going to fail on the ocean, because the ocean is such a chaotic and destructive environment. Any component that you add just increases the chance of failure dramatically. Now our research found that there is about 80 million kilos of plastic floating around, which constitutes to 1.8 trillion pieces of ocean plastic inside the Great Pacific Garbage Patch. So these results now allow us to further improve our cleanup technology And it also gives us a baseline to which we can compare the success of the cleanup. So we know the point where we start, and then while we're cleaning up in the next few years, we can continue to measure how much plastic is out there and then compare it to the baseline and see how far we've come. Well, of course, the obvious thing is that we want to get this first system working, and we want to scale up and really get to that 50% cleaned in 5-year target. What we'll be launching in September this year is actually one out of the many systems that we'll be deploying. So it's just one big 600-meter system, and eventually we need 60 of those to really rid the ocean of plastic. So, but first it's really key that we get one to work, show the world that it's possible, and then we'll have to raise the money required to then do the scale up.